Hey everyone, welcome back to another video of mine, where today we're going to be solving Leetcode problem 1004 titled Maximum Consecutive Ones Problem 3. So we're given a binary array nums and an integer k, and we simply need to return the maximum number of consecutive ones in the array if we can flip at most k zeros. Right, so in example 1 we have a nums input array of 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 1, 0. And with our k being 2, that means we can flip at most 2 zeros within our input array. Right, and our output would be 6 because that is the length of the longest window that has the most number of ones consecutively, right? Because in this part of the array at the end, we can actually flip 2 ones to have a length of 6 here, or basically 6 ones consecutively, right? Where it says that the bolded numbers were flipped from 0 to 1, and so the longest subarray is underlined, which has a length of 6, which is ultimately going to be what our output is. Okay, so if we apply that same logic to the nums array of example 2, our output would be 10 using that same logic. And yeah, so our constraints here say that the length of our nums array is going to be less than 100,000, where nums at I is actually either 0 or 1, so it is actually binary, and k is going to be within the range of the length of our input, right? So what I'll do is I'll actually have a variable that just keeps track of the longest length that we're currently looking at stored in one current iteration of the array. So I'll have our longest length, right, to be set to 0 because we haven't actually iterated through the array yet, and so we haven't actually got a longest length yet. So we'll just initialize that to 0, right? And then we'll have a number of zeros variable, right? And this is also going to be 0 because of course we haven't scanned through the array yet, right? And the number of zeros is just going to check for the number of zeros that we have in one window in our current iteration of the input array, and you'll see how that goes, right? So we'll actually use a two-pointer technique here to keep track of a window. And so what I'll do is I'll have the first pointer, L, basically equal to 0, or the 0th indice, and I'll use R to actually expand through the array. So I'll say for R in the range, for R in the range of the length of the numbers, okay, interesting. For R in the range of the length of the numbers, right, if nums at that R, right, if the current element that we're looking at that Rth indice within our input array nums, if that's actually equal to a 0, then we actually have to increment our number of zeros by 1, right, because we've seen another 0. And you may be wondering, why are we even keeping track of how many zeros we see in a window? How does that actually help us? And you guys will see how in just a second, right? If nums at R, their Rth indice, if that actually has a value of 0, we'll increment the amount of zeros that we've seen with our input array in one current window in this iteration by 1. Right? And we'll keep doing that as we expand through the window and check for more zeros. Right? So if nums at R is equal to 0, increment that variable by 1. Now we have to actually check if, right, using an if conditional statement, if the number of zeros, right, if the number of zeros that we're currently looking at in this window, if that's actually greater than k, right, so if there's actually more zeros than we can flip, this isn't a valid window, okay? So if that's actually true, then what we need to do is we need to do the following. In fact, this should be a while. Right, while it's true, we need to do the following. We need to check if nums at L, if nums at L is actually equal to 0, then that's another 0 that we've encountered. So what we want to do is we want to decrement our number of zeros by 1, right? And then we want to expand our window. So we want to get our left pointer by 1 greater, so more right in the array, right? So just to recap what lines 10 through 13 do, while the number of zeros is actually greater than k, so while that condition is not met, or while that condition is true, if the number of zeros that are in the current window, if that's more than k, or more than the number of zeros that we can flip, this isn't a valid window. And the reason why is because even if we flip at most k zeros, we're still going to have more zeros in this window, and so it won't be an array or a subarray within this input that actually has solely zeros, and so, or solely ones, and so it's invalid. And so while it's actually invalid, we actually have to increment our L pointer by 1, just to make sure, right, just to make sure that we get to a valid statement. And the reason why we have this conditional here is that if nums at L ever hits 0, right, if as we're expanding the Lth indice in our input arrays, if that actually has a value of 0, then let's just decrement our number of zeros by 1, such that we have an accurate count of how many zeros we have in this current window. Alright, and we'll keep expanding our window rightwards using our left pointer, right, using our L pointer. We'll keep going more right by incrementing it by 1 until we actually have a number of zeros in our current window less than k, or equal to k. Basically, we'll have enough zeros in our current window that we can actually flip using the k variable, right? Or in this case, parameter. Right, so while that's true, we want to increment our L pointer by 1 until we actually have a valid window with less zeros than we have k. And then we actually have to set our longest to be the maximum value of the window, right? So the maximum value of course, itself, and a window which is defined to be r minus L plus 1, right? The rth indice minus the left indice plus 1, right? That's basically the standard size for a window in the two-pointer technique or algorithm, right? So now that we've got that longest out of the way, we can simply return the longest, because this longest is going to have stored the maximum value or window length of our basically r minus L plus 1 for every single valid window within our input array nums. And if we were to submit this, unless I made any incorrect syntax issues or something, okay, let's see. Okay, this should be longest length. Sorry about that, guys. And the reason why it's actually longest length is because I declared it on line 3 to be equal to 0, the longest length variable name. And so now that should be correct. And longest, okay. So it looks like I have another issue. There should be also longest length. Sorry about that, guys. Okay, let's submit it again. And it should be accepted now. As you can see, it's quite efficient, beating 98% memory-wise, and although I only beat 30% in runtime, if I were to submit this again, it would just skyrocket up to like 80%. So yeah, 55%. So you really can't trust these numbers on Leetcode when it says you beat a certain percentage of users, because it's ultimately random, right? It really is random. So if you guys enjoyed this video and learned something new, please make sure to like and subscribe to my channel. It really means a lot. And without further ado, I'll see you guys in the next video. Bye-bye.